Now what I want to do is I want to skip the deltas are weird. That's what we've learned. The deltas are weird. So break if you're an OFS delta or if you're a ref delta. So let's do a is delta or something like that. Okay, so we're gonna, I guess we'll just match. We can just, we can do a matches. So matches, we have our self here. And if you are object type, delta, or object type oh, it doesn't like that. Expect unit struct, unit variant, or constant found tuple variant. Okay. Oh, single pipe. Oh, right, because it's a match, not an actual normal or. Okay, so there we go. Okay, so is delta checks that now. So we have our back to clone. So instead of matches here, we're just going to do if object type is delta. So if you're a delta, attempting to handle delta object type, and then we get the object type, and then break. Okay. So now we do this. Ref delta. Okay, we got a ref delta, and we see that that is 7. But in the meantime, you know what? What if I just stay out here and we do a LT get sample 3 get like that. We have 1, 2, 3, 4, 5, 6 things now. Okay. So that means we have 4 commits, a tree, and maybe an object of some kind. Which is nice, but this is where we have to handle ref delta now. Great. Okay. So ref delta. Conceptually, there are only 4 object types. Can you do continue instead of break now? We could try, yeah. Let's try it. I'm betting that no. I'm thinking that it will still crash, but maybe not. Yeah, okay. Panicked, okay. Corrupt deflate stream. So I think the problem, which did you mention it or somebody had mentioned it? I think it was you. That the size is wrong. So like the way we're extracting things is perfect for normal types, but if the object type is a delta, then the size is not correct anymore. And we have to handle it differently. Esitsu, okay, probably. So Now we know let's see, in here, I get the object type right away, and then, okay, so then we get the size here. So in keep bits, we grab, okay, so we grab you. And then read size encoding. Huh, none of these have unwraps in them. Oh, but you know what? I do have question marks. So read size encoding, I wonder if this is where we run into issues. No, wait. It can't be that. Because we see we're attempting to handle delta type ref data, and then the next one fails. So it's okay, so it's the next one that fails because the next one is at the wrong location inside of it. Okay. So we need to at this point in time, if it turns out that this object type is a ref delta, we need to do something else and like then speed forward in our pack file reader and either skip it or handle it at this point in time differently. Both OFS delta and ref delta store the delta to be applied to another object called base object to reconstruct the object. The difference between them is ref delta directly encodes base object name. If the base object is in the same pack, OFS delta encodes the offset of the base object in the pack instead. The base object could also be delta-fied if it's in the same pack. Ref delta can also refer to an object outside the pack, the so-called thin pack. When stored on disk, however, the pack should be self-contained to avoid cyclic dependency. The delta data starts with the size of the base object and the size of the object to be reconstructed. These sizes are encoded using the size encoding from above. The remainder of the delta data is a sequence of instructions to reconstruct the object from the base object. If the base object is delta-fied, it must be converted to canonical form first. Each instruction appends more and more data to the target object until it's complete. There are two supported instructions so far, one for copy, a byte range from the source okay. Each instruction is variable, of course. Instruction type is determined by the 7th bit of the first octet. Oh, okay, great. Add starts in, okay, so break time starts in 5 minutes. Okay, so instruction to copy from base object. This is the instruction format to copy a byte range from the source object. It encodes the offset to copy from and the number of bytes to copy. Offset and size are in little endian order. Was the other one's big endian order? All offset and size bytes are optional. Optional? This is reduce the instruction size when encoding small offsets or sizes. The first 7 bits in the first octet determines which of the next 7 octets is present. If bit 0 is set, offset 1 is present. If bit 1 is set, offset 2 is present, and so on. Note that a more compact instruction does not change offset and size encoding. For example, if only offset 2 is omitted, like below, offset 3 still contains bits 16 to 23. It does not become offset 2 and contains bits 8 through 15, even if it's right next to offset 1. In its most compact form, this instruction only takes up 1 byte, with both offset and size omitted, which will have default value 0. There is another exception. Size 0 is automatically converted. Okay. Business, it's construct turret object without the base object. All right, original. I don't think we have original. I think we have like the modern stuff. Version 2 pack, okay. Oh, but these are IDX files. We don't have an IDX files. We have like an actual pack file. Okay, so this is fun. I kind of want to see what it is that we have here. Because clearly we have a delta representing the rest of the stuff. Which kind of sucks. Let's just read up the first byte and print it out in the case that it's this thing. So in clone, we're in delta. Continue doesn't work, so we're gonna have to break. But before we continue, let's grab the next okay, so I want the next byte. So we're going to do let mute next byte so I just want one of you. Let's do our cursed pack file. I don't want to read end. I want read exact. Okay, read exact. Next bytes. And then I guess we'll print these out. So we'll just debug next bytes. Business Maker, hello. How are you doing today? What do you think is the best top-down? Okay, what do I think is the best? Top-down or isometric Metroidvania? Top-down feels... Are there any examples of top-down? Would we consider a Zelda game a Metroidvania? That doesn't feel like a... It doesn't feel like a Metroidvania. Oh, sorry. Ad break just started. I totally forgot that we were in the middle of this. Like Zelda 1. I'm talking about like the original OG Zeldas. Bizmaker, if you get an ad, let me know and we'll pause until the end and then we'll continue the conversation right after that. Actually, you know what? We're gonna pause anyways because I need to go use the restroom really quickly. No ads for you? Okay. That's good. So I guess Link's Awakening, I never played the original. I've only played like the OG Legend of Zelda. And some of the other ones, but I never completed them. I always thought that oh, RL, you got the ad this time. Okay. I've never considered top-down anything to be like a Metroidvania. Even though I can definitely see elements of Metroidvania in there. So I can definitely see that. Isometric is like the remade Link's Awakening, right? I don't think that there's one is better than the other. I think that they both can be really good. I am terrible at Metroidvanias, by the way, so I'm a little bit biased against Metroidvanias, mostly because I get lost in them and I sort of like forget what I'm doing, forget what I'm going. I need a lot of player assistance inside the game to help me out. Otherwise, I just get frustrated with like the map and everything else inside of there. So that's the problem I have. We have 1 minute left on the ad break. I'm going to take a super quick, less than 1 minute break, and I will be right back. All right. Oh, thanks anyways. Hopefully, like, I guess like, so that's my thoughts. I like both top down and side games. I guess like top down and isometric. I like both of those. So I guess I don't have any skin in the game is really what it comes down to. Are you trying to make a game and you're trying to figure out like which one to go with? Okay, so our next bytes, 182. So this is a U8. Okay, I want to turn this into binary. Can I do this with a format? Next, okay, let's, next bytes. Some byte like that. Maybe this might work. This might give us what we want. Okay, so here's what we have. We have our binary number 10110110. So let's see if we can figure out what this means. So instruction to copy. Yeah, okay. So instruction to copy from the base object. And these are 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the first one, right? So you're always going to be 1. Interesting. Okay. It encodes the offset to copy from and the number of bytes to copy. Offset and size are in little endian order. Note that a more compact instruction does not change offset and size encoding. For example, if only offset 2 is omitted, like below, offset 3 still contains bits. Oh, weird. Okay. So we have 4 offsets and then 3 sizes. So looking at that, we have always 1, and then we have offset 1, 2, 3, 4. And so we have offset 0, 1, and 2. Okay, so offset 1 and 2 are set for us. And then offset, I guess technically the way we wrote this here, offset 2 and 3 are set. And then 1 and 4 are zeros. And then we're going to have the sizes. How do I get the sizes for this? Because like obviously it's just 1 and 0, so that's not helpful. Does this guide have anything with ref delta in here? Yes, okay. Undeltified objects. Okay, so that's fine. Deltified objects. There we go. So far, we've seen how to find an object in a pack file and read its compression representation. However, we're still missing the main motivation for pack files, being able to save space by storing one object in terms of another. This is where the offset delta and hash delta object comes in. The idea of a deltified object is simple. The object is formed by combining chunks copied from a base object with new data. Ideally, the two objects are very similar, in which case only a few large chunks need to be copied and little new data needs to be specified. The only difference between the offset delta and hash delta types is how the base object is specified. A hash delta uses the object's 20-byte hash, whereas an offset delta specifies its position in the same pack file. Okay, now they're using hash delta. Okay, so there's offset delta and then hash delta. And up here, the 6, offset delta and then ref delta. So a hash delta, which is the ref delta, uses the object's 20-byte hash. An offset delta specifies the position in the same pack file. The offset representation is shorter and makes it easier to locate the base object, but it doesn't allow for base objects outside the pack file. We'll start by decoding at the offset of an offset delta, which is number 6. It uses a but we have a number 7. So we have a ref delta. Okay, so we need to get the instructions are distinguished by the upper bit of the first byte. A data instruction starts with a 0 bit, while copy instruction starts with 1. Okay, so that's... Oh, interesting. Okay, so a data instruction starts with a 0, which I think we saw here. Copy. Whereas down here, data... Okay, that's interesting. In a data instruction, the remaining 7 bits indicate the number of data bytes that follow. Okay, but we're going with copy to begin with. A copy instruction is followed by an offset up to 4 bytes and a size up to 3 bytes to copy in a base object. Okay. I keep on mistaking how this works. So if we look at you, those 4 are the offset. So we have 0, 1, 1, 0. So if we start with 1, 2, 4, that's 40, 42 is our offset. And then the amount of data would be 1, 2, 4. No, that's too small. That's too small. That feels weird. The mask size of the instruction is 7 bytes plus the first indicator byte. The first indicator byte tells you which of the next bytes is available. If bit 0 of the indicator is set, the offset 1 byte is available. If bit 4 is set, the size 1 byte will be available. This is where, like, I wish that there was examples in here, because this type of math is, I don't know if it's like hard for me, but like it's hard for me without examples. I usually need it like solved first, and then I can like reverse engineer it a lot easier than me like figuring it out from this type of documentation. The bits themselves are not telling you the size. Okay, that's good to know, but I guess it's still not helpful to me. They're only telling you which of the next bytes you need to read. Okay, so hold on. This instruction to format a byte range from the source copy and encodes the offset to copy from and the number of bytes to copy. Offset and size are in little endian order. Little endian is left to right? I think it's left to right, right? All offset and byte sizes are optional. This is to reduce the instruction size when encoding small offsets or sizes. The first 7 bits in that first octet determines which of the next 7 bits is present. Oh no, it's right to left. If bit 0 is set, which is that one, offset 1 is present. If bit 1 is set, offset 2 is present, and so on. Note that a more compact instruction does not change offset and size encoding. For example, if only offset 2 is omitted like below, offset 3 still contains bits 16 to 23. And it does not become offset 2 and contains bits 8 to 15, even if it's right next to offset 1. Okay. In its most compact form, this instruction only takes up 1 byte, with both offset and size omitted, which will have default value 0. There's another exception. Okay. All right, maybe you'll have better. A copy instruction starts with 1. A copy instruction is followed by an offset up to 4 bytes and a size up to 3 bytes. Oh, bytes, not bits. And a size up to 3 bytes. Okay, to copy into base object. The lower 7 bits in the instruction byte indicate which of these offset and size bytes are present. For example, consider this copy instruction. So we have 1, scissor 1, 0, 1, 0, 1. Okay. Only bytes 0 and 2 of offset are provided. Okay, so we have copy instruction here. Only byte 0 of size. Oh, this is okay. So I've got it backwards in here. So this is the size, and this is the offset, right? No. Okay, I'm still confused. Okay, so it is right to left. Is this reversed? Is this a binary number reversed, where it has, this is the far left of the binary number, and then everything else is like backwards because it's little endian? I wish they didn't do that. Oh, okay. It makes it harder for me to like actually just print this out and look and understand what's going on. Okay, so we have, this is byte 0 of size is provided. Little endian is right to left, but the offset and size byte orders are correct in that picture. But wait a second, this is showing these three in this number here. This is the size, which would mean that this is the size. So I want of the next bytes, I want to skip one and then get the next one as the size bytes. And then I want the offset, which is skip, offset, offset, skip. Is that, am I reading that correct? Or is it actually opposite way around, where it's like, well, I guess in this case would be the same because they're the middles, but it would be offset. So skip offset, take offset, skip offset, take size, skip size. No, you don't skip anything. The skipped ones are not present in the byte stream at all. The first byte after this is going to be offset 2, which would be that one. Oh, okay. So they don't put that in there. Okay, so we're going to have, it's not present. So by skip, it just means not present. So we're going to have offset, offset, size. Is that what we're getting? Offset, offset, size. Okay, you read that byte and call it offset 2. Is that, oh geez. Here's the lengthy implementation. Keep in mind, we are just repeatedly reading an enum delta instruction. Data vec. Okay, so we have our data vec 8 and then copy size. Okay, then offset 3, non size 2. What I guess like the thing that is just weird is the fact that, okay, why do I have to call it offset 1 and offset 2 when it's just, I guess, like, does the offset numbers actually mean anything at all? And do I have to keep track of those? Or is it just, we have 2 offsets, and do I add the offsets together? Like, I'm still confused about that. That's the same reason the dev.to article example also only has 3 bytes. The instruction has only 3 bits set. Okay. And then here's our implementations for this. So we have our copy instruction flag, which is 1 bit shift left to the 7. So that's going to be that far left one. Copy offset bytes is going to be, okay, we have 4 of those. Copy size bytes, so 3 of those. Copy 0 size if it's nothing. Read an integer of up to bytes length. Okay, so read partial int. Now, do we have partial? We have the read. We had var int byte, and now we have read partial int. Okay. Reads a single delta instruction from a stream and appends the relevant bytes to result. Returns whether the delta stream still had instructions. And so this gives me the result out. And then we have apply delta, which it reads the apply delta instruction. Okay. And then we return the object type and then the contents as a result. The delta format seems unnecessarily complex to me. Why does it need 3 different variable length integer representations? If we ignore the details, though, we can see that a delta is really a generalization of a diff. In fact, Git often uses previous versions of blob and tree objects as base objects for the next version's deltas, just like Git diff would do. Instead of comparing on a line-by-line basis, though, the delta works with individual bytes. The chunks copied from the base object also do not need to be in the same order that they were in. But the benefits are exactly the same. When the changes are small, storing a diff reduces the amount of duplicated data. So pack files really do give Git the best of both worlds. Storing blobs for every file at every commit makes Git checkout very fast, but storing them as deltas and pack files keeps them from taking up excessive space. Okay. So we're not... Interesting. So it's just the differences that are being stored, that are being returned to us, as opposed to every file. Oh, okay. Okay, so now we can fill in the remaining cases and read pack object. All right, so first off, we have to handle this type of stuff. And that's where our size problems are coming in. Because the sizes are, well, different, because we need to read them in a different way. Because it's inconsistent, yay. So really, in read type and size, I now need to create the type and then handle the size in a different way. Oh, and then grab the actual data out, which would be this here. We have our content type, we have our object type, which is going to include the size of it, and then we have the contents, which is a result. And obviously, this could be an option because only the deltas would have the contents. Right? Only No, I only care about the object. Okay, so I can get the object type and then the size, and then we read that in via different thing. Shoot, okay. No, I'm gonna have to I have to get the data for it right then, don't I? Wait, no, I don't. Do I? I need okay, so if you're this, I don't have the contents net yet. I have the okay. Am I able to grab just the size out? So like I need to get the content type, the object type here. So like no matter what, we need that. And so we get this. But then the size is gonna be vastly different now. I think it is. I think I still get the result size. Okay, so if I don't get this out here, I could get the size separately and then say, okay, now process it and get me the thing in another function, as opposed to all together at once. I think that's what I would need to do. So if we update you and just say, okay, keep bits, just do an object type, new that gives us an object type. Oh, but I need this. I need the size, but the size is different. Oh, okay. No, but this is fine. Yes? Or wait, does it not matter? Now my brain is breaking down. Okay, so we figure out that you're a delta. If you're a delta, I guess like I probably need to like check to see exactly what type of delta it is, because it's probably a different method of going through it based upon the type. Okay, so if you're a delta ref, no, not a ref. If you're a hash delta, which is number 7, all of this stuff changes. So this kind of becomes an else here. So I wonder if I want to do a match on the object type. So if we match object type, and then we'll probably have a function to handle all the, like the different things here. Okay. So if you're commit, we're going to get the size. And instead of to do, I want to do these things, but maybe down here. So we just like maybe have a function handle normal object type, because yeah, we're going to take in, do I want to pass in the object type? I do. I want to pass in the object type, but I could pass in the, I only have a reference to it, and I don't really need mutable ref. Okay, so we'll have the object type. So then I don't need the size here, or I pass in the string. I pass in the string at this point. That makes more sense. Okay, so then we have our size, which is a U size, and we have our object type, which is a str, and we return the hash. So the result with a vec of U8. And then all of this gets returned here. Right? Yes. So delete you, throw you in here. We have our hash. We're now going to return an OK with the hash. Oh, I need the cursor with the pack file. So we need the cursed pack file, which is a reader. So R, which implements read. Cursed pack file, oh, which you need to be mutable. Why don't you work? Method position exists for mutable reference R, but its trait bounds were not satisfied. Really? I thought I could do that with, oh, do I have to tell it that it's actually a cursor as opposed to just an R? Maybe. Might be seekable. Okay, let's try that. Read plus seekable. I don't see a seekable here. Is there a cursor? No. Okay, so what if instead of R, we just say you are a cursor of what did we decide you're containing? A reference to U8. Okay, so then you're happy here. Asitsu, welcome back. Hello. Oh, cursor R would be fine. Okay. Ooh, but what type are you? How do I lock you down? Do I lock you down? Maybe. Object type, get size. Oh, I need object type. Oh, but I don't need to get size because now we have the size. So we have our size in here. We created a decoder with the cursed pack file, but we already have a mutable reference to. The trait bound R as ref U8 is not satisfied. Cursor required for cursor to implement. I'll read. Okay. Oh, because does an array implement R? So read like that. Doesn't like that. Unless I need that to be something like that. Nope. The trait read is implemented for cursor T. The trait bound. Oh, wait. You need to be owned. Seek would be fine if you switch position with stream position. Wait, but seek would be fine, but I'm worried. I'm working on the zlib decoder right now. So, cursed pack file. The trait bound R as ref U8 is not satisfied. Required for. Oh, does it? Is that need to be reference to R? No. Does that change the error message? As ref U8. Oh, so we need to add in as ref. So plus as ref U8. Okay, so the trait bound R as ref U8 is not satisfied. Required for standard cursor R to implement standard IO read. One redundant requirement hidden. Required for mutable reference cursor R to implement standard IO read. I am Steve-O. Hello. How are you doing today? U8? Oh. Like that. There we go. Okay, we got it. Was I just not actually reading the error message? It probably actually had the brackets around it, didn't it? Okay, so that makes all of these happy. Now, get type. No method get type found anymore because now I have, we don't need this anymore. So object type, get type. So it's just object type now. So actually I can do this. Object type, and then we don't need the size because we have the size like that. So that makes you happy. Oh, target directory. So we need to pass in the target directory too. Target directory is, I think, a string, not a path. So that might be okay. Yeah, target directory is a string. When do I create the path? A Apparently never. When did I create it before? I don't think I deleted it. Oh, target directory. That's what it is. Okay. So target directory becomes a path buff. Okay. We can do that. So this will be a path buff. Here, we'll just make you that. That makes you happy. You probably don't need to be cloned because we only have one of you in here. Curse pack file seek. Borrow move value, curse pack file. Okay, so curse pack file, I pass in. Oh, I was trying to pass in a mutable reference, but apparently that won't work. So here, reference to you. Oh, you need to be mutable? No. Hold on. You're fine. Bar move value, zlab decoder. See, I do make you mutable reference here. You don't need mutable. Spam, hello. How are you doing today? Sometimes the brain just reads over stuff. I'm used to it. I do that all the time. Are you doing fine? Great. I am, my brain is definitely feeling it today, or at least this afternoon at this point. I think all the binary math is harder on me than some of the other things that we do. Which mostly is practice. That's usually what it is. Okay, so curse pack file. Now I give you ownership of this, but then I seek you. But is curse pack file a smart pointer? Can I actually clone that? Is cursor a smart pointer? You know, if I borrow you, so if I borrow you, you're upset. So the trait bound mutable scenario cursor read is not satisfied. Okay, so you need to be mutable. But then, okay, cannot mutate immutable variable curse pack file. Cannot borrow curse pack file as mutable as it is not declared as mutable, which this binding is already a mutable borrow. What? That feels weird, but that fixes it. Yeah, I think that's exactly what it was, Skimus. Okay, so now you're happy. So now I can handle normal object from this. It does feel weird, doesn't it? Okay, so this is going to be handle normal object type. Okay, size. So we have our size. Our object type is a commit. We have our cursed pack file, and then finally our target directory, which we have to clone. And then mismatch types, expected unit. Okay, found a question mark that you. We are going to let our hash equals to this. Okay. Size We dereference you. Okay, and now we have our hash that. So now we want to do the same thing for tree, blob, and tag. So we get our size. Oh, but we learned that we can just do this here, and that should work. We're going to call handle normal object type, hand it the size, hand it the okay. There are cursed pack file. And then what are you? You're the target directory. So let's target directory and we clone you. What is, can you do all those with a pattern to avoid duplication? Oh, I pass in a label. So not like I can if I could call, I have a label thing that I could call from object type. That seems a little bit weird. So, I mean, probably yes. Also, what are you upset about? Oh, okay. So I can't actually pull it out like that. I thought maybe I can get lucky or get cheat, I guess, a little bit. Okay. Match arms have incompatible types expected to struct. Wait, don't you return? Handle object type returns that. Oh, right. I forgot to. Nope. What? What did I do? Where am I? How did I go to the end of the file? Where? All right. Don't do multi-cursors when the other one doesn't match. All right. So I need to multi-cursor here. Do that. There we go. Okay. Right. So what is a normal object? So a normal object in this case is a commit, a tree, a blob, or a tag. So normal in the context of a Git object. And so all of those are actually just files that we can store into the .git/objects directory. But we have offset delta and we have a ref delta, which are themselves different, and we need to handle them differently, which sucks. So this is okay. So this is how we can handle our hashes. So this exact same thing should work here. So I should be able to, I guess right now we're not doing anything. So I will underscore that. We have our handle type. I've quit everything else. Yes, everything else in this function is gone already. So now, no, this is not gone. So let's, right now I'm ignoring the pack file. I guess I'm ignoring things if it's a delta object, and then you just crash as soon as we handle that, which is kind of the same thing that we're doing right now. We're just breaking, but then that's the same thing. I guess it's not really the same thing. We're breaking is just the skipping it, which is here. Okay, here's what we can do. Function handle OFS delta. I don't know if these need to be different or not. function handle. I'm pretty sure they do though. Ref delta. Now these, I think we get the size, but I think we don't care about that. Now I could call this, but it's going to crash when it comes back around to try to handle it. But we'll just call handle OFS delta. Now you're going to start yelling at me because the hash is not the same, which means that you need to be probably a sum here. Okay, so we have a sum hash. Okay, which means that you all return. I don't know what these are going to return. Like I don't have what the other thing is. So we're going to say, I'm going to multi-line you. Return to none. Cool. Okay, so. Oh, I have to handle the size, so we have to do that. We'll do the same thing here. So we'll handle ref delta, then return a none, and then if you happen, we're going to do unreachable, because it technically should be unreachable at this point in time. Okay, and then errors. Semicolon U. Wow, it's been an hour already again? Oh, crazy. Time does fly during these streams. At least for me. Okay, so this should be exactly the same right now result that we get, which is we crash. Called result unwrap on error, corrupt deflate stream. Okay, so we crash at this point in time. Time flies when you're having fun. Yeah, although like even if the fun is breaking my brain, like that's definitely something that happens. Okay, so what I can do now is we can start playing with you. So we can say ePrint line attempting to handle OFS delta. Attempting to handle ref delta. And I believe it's the ref delta that happens right before we crash. Attempting to handle ref delta, and then we crash, and it's terrible, and it's horrible. Okay, so then this point in time, is there something that we can, is there a jump point for this? Delta instructions, not really. So let's do at that. So that way it's a reminder for me of what to do next time. I'm going to go ahead and snooze the ads a little bit. I don't actually think that I'm going to let the ads play. I think we're going to end right before then because I don't know if my brain can handle the full going through, and this feels like a lot, and I think I should be fresh when we try to do this. So the plan is next week on Monday, I'm going to see this. and we're going to go through this. We're going to implement using the Delta instructions here. We'll come here and we'll see the Delta instructions, and we have to implement all of these and potentially all of this stuff, which is fun. So that's going to be interesting, and sort of like try to figure out what the heck are those things. It's from what I can tell reading through this, they're diff objects, which are not the same as the other thing. So we might have to do new gets or something else to figure out like what exactly we have. But that's a future me problem. So in a week, when I ask, okay, what am I doing? How did I do this? What's going on? I can thank present me for basically saying, I don't want to do this now. All right. Let's see. That's, I think then we can just call it a day. Let's go ahead and get this sent on up. Obviously this is not working right now, but we're a lot closer. Also, I keep on having this test file saved. Why do I have a test file? I don't want buffer close you. Oh, right, because I have this dev save the file, which I don't want anymore. So dev save the file, remove you. Okay. No more warnings, no anything else. Let's remove test file. Let's get commits. All right, so what are we doing? We are handling basic object types. Also prepped to handle ref type. Not ref types. They are... Snooze one more time. They are delta types. Okay, we'll go ahead and push this on up. Obviously, this is going to fail, and that's okay. And so with that being said, I think, yeah, crash, which is perfectly understandable at this point in time because that's exactly what's happening. Okay, I don't think I have anything else. We've saved the code. I think I got everything else up. Next week, we'll continue on with this. Tomorrow and Wednesday, we're working on the Docker course. And we left off where the Docker, we've written all the first path-throughs for the articles. So now we're at the point where we're going to reread the articles, make sure that they make sense, and then create videos for each one. And then the course will be done. So I don't know if we'll be done with all the videos by the end of this week. So, you know, tomorrow and Wednesday, we have long days. So we might get all the videos done. But next week might be more safe to know. And once those are done, I get to upload them, put them on the LMS, and we get to start selling. So anyways, everybody, thank you so much for hanging out today. Hopefully you all have a great rest of your Monday. Oh, a lot of people are streaming right now. Okay, who should we raid? At least on the Twitch side. Let's see, Teach Dev is streaming. I guess the person who has the least number of CM Griffin is making Vexilla, which is a feature flagging for everyone. And CM Griffin raids us every once in a while. So I think it's been a while since we raided him. Let's go ahead and set a raid for CM Griffin. So I'm gonna do a raid. CM Griffin. All right, everybody, thank you so much again for hanging out with us today. I hope that you all have a great rest of your day, and I will see you next time. Bye.